Hello students, this class is about the normal distribution and their practical example in R. I have already uploaded the document on the basis of normal distribution, which shows that a normal distribution is defined as this: fx is equal to 1 upon sigma root 2 pi e to the power minus x minus mu square, so 2 sigma square, where mu is the mean and sigma is the variance. Sigma square is the variance, so sigma is the standard deviation. The R function for this, that will mainly will use this function p norm, where I have to give q and mean, standard deviation, and the other thing that we have to give is the lower dot tail. What the lower dot tail is, it is a logical value. If it is true, then probability is given for x less or is equal to x, that is the lower portion. Otherwise it will give the upper portion. So if it is false, we have to give upper portion. An example will make it clear. So the example that I will take here is this one. The height of adult females are normally distributed with mean is equal to 160 and standard deviation is equal to 8 centimeter. The first question is this: find the probability that a randomly selected adult female has a height greater than 170 centimeter. So this is the probability we have to find out. So let us first solve this using our mathematical tool. So always we will use, to solve it, I will use the graph, that is the Gaussian curve for this. This is kind of Gaussian curve that this generates, where this is 160, here I will have 160, right? And it is said that the probability that a randomly selected adult female has a height greater than 170. So I will just come back here. See, 170 will fall somewhere near this. This will be somewhere near 170. So I will just copy, I'll just pick another standard Z curve. I'll draw another standard Z curve here with this value is 0, and with this in mind, I'll draw this as Z. So this is my x, which is equal to 170. Now I will follow a formula which says Z is equal to x minus mu by sigma. So here I know that x is equal to 170 and mu is the mean, which is 160, by sigma, which is 8. So this becomes 1.25. So actually my question now becomes the probability. The question now becomes probability of x greater than 170, and this is I have found that this is equivalent to probability of z greater than 1.25, money this one. So if I find if for z this whole value is 1, the whole probability is 1, so if I find 1 minus this portion, then I will have Pz is greater than 1.25. So this is actually 1 minus P 1 minus P Z less than 1.25. Right. So this value Z 1.25 can be obtained by following this table. I will provide you this table after the record. So let's find out what is 1.25 here, minus 1.25. I'll find out here 1.25 this value. So I'll just take it out here. So basically this becomes equal to 1 minus this value, which is will be approximately 0.105. So that value that we need. So this is my answer, 0.105. How to find out this? Using R. So let me open R. For R I have told that we will use pnorm function. So for R I will go here and I'll just type pnorm of where q is equal to 170 and here mean equal to 160, st equal to 8, that is the standard deviation, and I need the upper tail, so I will write lower tail equal to false, because I need the x value which is greater than something, greater than 170. So here I will get this value 0.1056498. That's my answer. So this is how you solve this kind of question. Find the probability that a randomly selected adult female has a height. Now for the second question I have this one. Any adult female whose height is greater than 170 is defined as tall. Now an adult female is chosen at random. Given that she is tall, find the probability that she has height greater than 170. So here basically two conditions needed to be satisfied. First, it is given that it is greater than 170, the height is greater than 170. What is the probability that the height will be greater than 180? So actually the x value is still at 170, but I will draw another curve here, another line here, which is on x is equal to 180, right? And here it is defined, it can be defined as a, I just delete the earlier one, so it can be defined as probability of x greater than 180 given that x is already greater than 170. So it's a conditional probability, and we already know what is the formula for conditional probability is if p a given b is asked, we write it as p a given b is equal to p a intersect b by probability of b. So that is the formula depending upon which I am going to find out this one. This is the formula that I will look. So here we need to find out see any value which is greater than 180 should also be greater than 170. So p a intersection b will turn out to be probability of a intersect b, that is probability of x greater than 180. That is the value that it's going to turn out, and the earlier one will remain the same, which is probability of x greater than 170. Probability of x greater than 180. So now you just need to find out this one, because in the earlier case we already have find out probability of 170. This is known to me. You just need to find out probability of x greater than 180. So I leave you with this, because you can as you know, you can find out which is probability of 170. You can find out easily what is probability of x greater than 180. You just need to find out z, and with this formula straight away x will become 180. So this becomes 180 minus 160 by 8. So it will become 2.5. So you will again have to move to the table and find out the value, and I am just leaving you with the answer. It will be 0. In this case the answer will be 0.05877. So this is how you solve the problem. And in case of R, we'll just find out, say A is equal to, I'll copy this one, and here instead of this I will just write 180, right, and B is equal to the so basically A by B will be my solution, which is 0.058, right. So it will match with my this answer, 0.05877. So this is how you find out the answer. Now I will go to another question, the third one. Half of the tall adult females have a height greater than 8 centimeter, find the value of age. Now this will be a interesting question. What we need to find out is probability of here what we need to find out is probability of x less than age, right? I do not know the value of age. It is given that half of the adult females have a height greater than age. So here, and see the half of the tall adult female. So where we will say tall. If it is greater than 170, I will say that it is tall. So let me just put age here. I'll just put age here. So basically this age is dividing this portion in two equal halves, because half of the tall adult females have a height greater than age. That means half of the tall female will have height less than age as well. So I am just interested to finding out probability x less than age, and that will be this value, right? So I'll just write 1 minus, so this half has to be added, so this will be 1 minus, see probability of being tall is probability is x greater than 170, so probability of half of this will be probability of x greater than 170 by 2, right? So this will be 1 minus, earlier case it was 0. This will be 1 minus 0.10565 by 2, which is equal to 0.947. So basically 94.7% of the female students will be in this area. They will fall in within the lower half of tall values and the rest. So only 0.06 will be here above the value of age. So where do I find out 0.94 in the log table? Here, let me come here, 0.946, right? 0.946 or 947. Here 1.62 is the value where do I find 0.947. So for z is equal to 1.62, basically I can write for this value, I can obtain that this happens for z is equal to 1.62. So that's my solution. For z is equal to 1.62, I get probability x less than age. But I need to find out x, right? So rather than writing this, I will just write here, I will write z is equal to x minus mu by h minus mu by sigma. So here H is equal to, I can write H is equal to, from this formula I can write H is equal to Z into standard deviation minus, or say plus 160, that is the mean, is equal to, say Z is equal to 1.62, this into standard deviation is 8 plus 160, and that becomes 172.96. So this is the result, 172.96. This is how you find out. Now, so this was all for normal distribution. Now I will end this lecture with an example on Poisson distribution, some example of Poisson distribution.